Hello, Small Anthropoids. This week we delve into Galileo Galilei's starry messenger. Galileo's Sidereus Nuncus, its name in Neo-Latin, was a bit like Elvis entering the rock scene of its time. New, exciting, and raised a lot of hell. Prior to its publication in 1610, the Roman Church required two simple truths from its citizens: church on Sunday, and the earth is the center of the universe. I'm exaggerating, but that's what it felt like to Galileo, a scientist whose life would revolve around finding clever and political ways to tell the church, you might want to check again. As I said, he's the rebellious rock star of the 17th century, and there's a reason he is in Bohemian Rhapsody saying thunderbolt and lightning, very, very frightening, and not Chief Inquisitor Father Vincenzo Maculano. Joking aside, Galileo towed the lethal line between church and science that would ultimately threaten him with torture and death. And the work that pushed him from loyal church boy to slightly less loyal church boy who also invented and played with telescopes is Starry Messenger. The words you are about to hear are the very first in human history, a time capsule, if you will, of humanity realizing the world is so much smaller and so much less significant to the universe than we originally thought it to be. In fact, it is hardly more than a speck, a fraction of the sun it orbits, and there are so many more suns out there with potentially even more planets. We are not special, and the church found that very notion to be blasphemous. In other words, they were scared. But Galileo was not scared by this thought, and neither should we. If anything, it makes life on Earth that much more special, and this moment that you listen, 1,000-fold more precious. You are about to hear the clock of history tick. Starry Messenger is 15 pages, 400 years old, and an urgent message direct from Galileo to you, someone who could believe him. Telescopes exist. Jupiter has moons. Our moon looks like Earth. And, most importantly, there is a galaxy out there, filled with millions of suns and billions of Earths, the same, or perhaps better, than our own. We are not unique, but even commonality finds ways to be exceptional, too. Feelings of small may happen, but we hope you find that small is not scary. Welcome to Small Anthropoids. The Starry Messenger, revealing great, unusual, and remarkable spectacles, opening these to the consideration of every person, and especially of philosophers and astronomers, as observed by Galileo Galilei, gentleman of Florence, professor of mathematics in the University of Padua, with the aid of a spyglass, lately invented by him, in the surface of the moon, and innumerable fixed stars, and nebulae, and above all, in 4 planets, swiftly revolving about Jupiter in differing distances and periods, and known to no one before the author recently perceived them and decided that they should be named the Medicean stars. Venice, 1610. Astronomical message, which contains and explains recent observations made with the aid of a new spyglass concerning the surface of the moon, the Milky Way, nebulous stars, and innumerable fixed stars, as well as 4 planets never before seen and now named the Medicean stars. Great indeed are the things which in this brief treatise I propose for observation and consideration by all students of nature. I say great because of the excellence of the subject itself, an entirely unexpected and novel character of these things, and finally, because of the instrument by means of which they have been revealed to our senses. Surely it is a great thing to increase the numerous host of fixed stars previously visible to the unaided vision, adding countless more which have never before been seen, exposing these plainly to the eye in numbers 10 times exceeding the old and familiar stars. It is a very beautiful thing, and most gratifying to the sight, to behold the body of the moon, distant from us almost 60 earthly radii, as if it were no farther away than 2 such measures, so that its diameter appears almost 30 times larger, its surface nearly 900 times, and its volume 27,000 times as large as when viewed with the naked eye. In this way, one may learn with all the certainty of sense evidence that the moon is not robed in a smooth and polished surface, but is in fact rough and uneven, covered everywhere, just like the Earth's surface, with huge prominences, deep valleys, and chasms. Again, it seems to me a matter of no small importance to have ended the dispute about the Milky Way by making its nature manifest to the very senses as well as to the intellect. Similarly, it will be a pleasant and elegant thing to demonstrate that the nature of those stars, which astronomers have previously called nebulous, is far different from what has been believed hitherto. But what surpasses all wonders by far, and what particularly moves us to seek the attention of all astronomers and philosophers, is the discovery of 4 wandering stars not known or observed by any person before us. Like Mercury and Venus, which have their own periods about the Sun, these have theirs about a certain star that is conspicuous among those already known, which they sometimes precede and sometimes follow, without ever departing from it beyond certain limits. All these facts were discovered and observed by me not many days ago with the aid of a spyglass which I devised, after first being illuminated by divine grace. Perhaps other things, still more remarkable, will in time be discovered by me or by other observers with the aid of such an instrument, the form and construction of which I shall first briefly explain, as well as the occasion of its having been devised. Afterwards, I shall relate the story of the observations I have made. It would be superfluous to enumerate the number and importance of the advantages of such an instrument at sea, as well as on land. But forsaking terrestrial observations, I turn to celestial ones, and first I saw the moon from as near at hand as if it were scarcely 2 terrestrial radii away. After that I observed often, with wondering delight, both the planets and the fixed stars. And since I saw these latter to be very crowded, I began to seek, and eventually found, a method by which I might measure their distances apart. Here it is appropriate to convey certain cautions to all who intend to undertake observations of this sort, for in the first place it is necessary to prepare quite a perfect telescope, which will show all objects bright, distinct, and free from any haziness, while magnifying them at least 400 times, and thus showing them 20 times closer. Unless the instrument is of this kind, it will be vain to attempt to observe all the things which I have seen in the heavens, and which will presently be set forth. Now, in order to determine without much trouble the magnifying power of an instrument, trace on paper the contour of 2 circles, or 2 squares, of which one is 400 times as large as the other, as it will be when the diameter of one is 20 times that of the other. Then, with both these figures attached to the same wall, observe them simultaneously from a distance, looking at the smaller one through the telescopes open at the same time. The 2 figures will appear to be of the same size if the instrument magnifies objects in the desired proportion. Such an instrument having been prepared, we seek a method of measuring distances apart. This we shall accomplish by the following contrivance. Let A, B, C, D be the tube, and E be the eye of the observer. Then if there were no lenses in the tube, the rays would reach the object FG along the straight lines ECF and EDG. But when the lenses have been inserted, the rays go along the refracted lines ECH and EDI. Thus they are brought closer, and those which were previously directed freely to the object FG now include only one portion of it, HI. The ratio of the distance EH to the line HI then being found, one may, by means of a table of sines, determine the size of the angle formed at the eye of the object HI, which we shall find out to be but a few minutes of arc. Now, if the lens CD we fit thin plates, some pierced with larger and some with smaller apertures, putting now one plate and now another over the lens as required, we may form at pleasure different angles subtending more or fewer minutes of arc. And by this means we may easily measure the intervals between stars, which are but a few minutes apart, with no greater error than 1 or 2 minutes. And for the present, let it suffice that we have touched lightly on these matters, and scarcely more than mentioned them, as on some other occasion we shall explain the entire theory of this instrument. Now, let us review the observations made during the past 2 months, once more inviting the attention of all who are eager for true philosophy to the first steps of such important contemplations. Let us first speak of that surface of the moon which faces us. For greater clarity, I distinguish 2 parts of this surface, a lighter and a darker. The lighter part seems to surround and to pervade the whole atmosphere, while the darker part discolors the moon's surface like a kind of cloud and makes it appear covered with spots. Now these spots, which are fairly dark and rather large, are plain to everyone, and have been seen throughout the ages. These I shall call the large or ancient spots, distinguishing them from others that are smaller in size but so numerous as to occur all over the lunar surface, and especially the lighter part. The latter spots had never been seen by anyone before me. From observations of these spots, repeated many times, I have been led to the opinion and conviction that the surface of the moon is not smooth, uniform, and precisely spherical as a great number of philosophers believe it, and the other heavenly bodies to be, but is uneven, rough, and full of cavities and prominences, being not unlike the face of the earth, relieved by chains of mountains and deep valleys. The thing I have seen by which I was enabled to draw this conclusion are as follows. On the 4th or 5th day after new moon, when the moon is seen with brilliant horns, the boundary which divides the dark part from the light does not extend uniformly in an oval line as one would expect on a perfectly spherical solid, but traces out an uneven, rough, and very wavy line as shown in the figure below. Indeed, many luminous excrescences extend beyond the boundary into the darker portion, while on the other hand, some dark patches invade the illuminated part. Moreover, a great quantity of small blackish spots, entirely separated from the dark region, are scattered almost all over the area illuminated by the sun, with the exception only of that part which is occupied by the large and ancient spots. Let us note, however, that the said small spots always agree in having their blackened parts directed toward the sun, while on the side opposite the sun they are crowned with bright contours like shining summits. There is a similar sight on earth about sunrise, when we behold the valleys not yet flooded with light, though the mountains surrounding them are already ablaze with glowing splendor on the side opposite the sun. And just as the shadows in the hollows on earth diminish in size as the sun rises higher, so these spots on the moon lose their blackness as the illuminated region grows larger and larger. Again, not only are the boundaries of shadow and light in the moon seen to be uneven and wavy, but still more astonishingly, many bright points appear within the darkened portion of the moon, completely divided and separated from the illuminated part and at a considerable distance from it. After a time, these gradually increase in size and brightness, and an hour or two later they become joined with the rest of the lighted part, which has now increased in size. Meanwhile, more and more peaks shoot up as if sprouting now here, now there, lighting up within the shadowed portion. These become larger, and finally, they are united too with the same luminous surface which extends over further. An illustration of this is to be seen in the figure above. And on the earth, before the rising of the sun, Are not the highest peaks of the mountains illuminated by the sun's rays while the plains remain in shadow? Does not the light go on spreading while the larger central parts of those mountains are becoming illuminated? And when the sun has finally risen, does not the illumination of plains and hills finally become one? But on the moon, the variety of elevations and depressions appears to surpass in every way the roughness of the terrestrial surface, as we shall demonstrate further on. At present, I cannot pass over in silence something worthy of consideration while I observed when the moon was approaching first quarter, as shown in the previous figure. Into the luminous part there extended a great dark gulf in the neighborhood of the lower cusp. When I had observed it for a long time and had seen it completely dark, a bright peak began to emerge, a little below its center, after about 2 hours. Gradually growing, this presented itself in a triangular shape, remaining completely detached and separated from the lighted surface. Around it, 3 other small points began to shine, and finally, when the moon was about to set, this triangular shape, which had meanwhile become more widely extended, joined with the rest of the illuminated region, and suddenly burst into the gulf of shadow like a vast promontory of light, surrounded still by the 3 bright peaks already mentioned. Beyond the ends of the cusps, both above and below, certain bright points emerged which were quite detached from the remaining lighted part, as may be seen depicted in the same figure. There were also a great number of dark spots in both the horns, especially in the lower one. Those nearest the boundary of light and shadow appeared larger and darker, while those more distant from the boundary were not so dark and distinct. But in all cases, as we have mentioned earlier, the blackish portion of each spot is turned toward the source of the sun's radiance, while a bright rim surrounds the spot on the side from the sun in the direction of the shadowy region of the moon. This part of the moon's surface, where it is spotted as the tail of a peacock is sprinkled with azure eyes, resembles those glass vases which have been plunged while still hot into cold water and have thus required a crackled and wavy surface, from which they received their common name of ice cups. As to the large lunar spots, these are not seen to be broken in the above manner and full of cavities and prominences. Rather, they are even and uniform, and brighter patches crop up only here and there. Hence, if anyone wished to revive the old Pythagorean opinion that the moon is like another earth, its brighter part might very fitly represent the surface of the land and its darker region that of the water. I have never doubted that if our globe were seen from afar when flooded with sunlight, the land regions would appear brighter and the watery regions darker. The large spots in the moon are also seen to be less elevated than the brighter tracts, for whether the moon is waxing or waning, there are always seen, here and there along the boundary of light and shadow, certain ridges of brighter hue around the large spots, and we have attended to this in preparing the diagrams. The edges of these spots are not only lower, but also more uniform, being uninterrupted by peaks or ruggedness. Before last quarter, this same spot is seen to be walled about with certain blacker contours which, like the loftiest mountaintops, appear darker on the side away from the sun and brighter on that which faces the sun. This is the opposite of what happens in the cavities, for there the part away from the sun appears brilliant, while that which is turned toward the sun is dark and in shadow. After a time, when the lighted portion of the moon's surface has diminished in size and when all, or nearly all, the said spot is covered with shadow, the brighter ridges of the mountains gradually emerge from the shade. This double aspect of the spot is illustrated in the ensuing figures. There is another thing which I must not omit, for I beheld it not without a certain wonder. This is that almost in the center of the moon there is a cavity larger than all the rest and perfectly round in shape. I have observed it near both first and last quarters, and have tried to represent it as correctly as possible in the second of the above figures. As to light and shade, it offers the same appearance as would a region like Bohemia if that were enclosed on all sides by very lofty mountains arranged in exactly a circle. Indeed, this area on the moon is surrounded by such enormous peaks that the bounding edge adjacent to the dark portion of the moon is seen to be bathed in sunlight before the boundary of light and shadows reach halfway across the same space. As in other spots, its shaded portion faces the sun, while its lighted part is toward the dark side of the moon. And for a third time, I draw attention to this as a very cogent proof of the ruggedness and unevenness that pervades all the bright region of the moon. Of these spots, moreover, those are always darkest which touch the boundary line between light and shadow, while those farther off appear both smaller and less dark, so that when the moon ultimately becomes full, at opposition to the sun, the shade of the cavities is distinguished from the light of the places in a relief by a subdued and very tenuous separation. In the large spots, there exist some holes rather darker than the rest, as we have shown in the illustrations. Yet these present always the same appearance, and their darkness is neither intensified nor diminished. Although with some minute difference, they appear sometimes a little more shaded and sometimes a little lighter, according as the rays of the sun fall on them more or less obliquely. Moreover, they join with the neighboring regions of the spots in a gentle linkage, the boundaries mixing and mingling. It is quite different with the spots which occupy the brighter surface of the moon. These, like precipitous crags having rough and jagged peaks, stand out starkly in sharp contrast of light and shade. And inside the large spots, there are observed certain other zones that are brighter, some of them very bright indeed. Still, both these and darker parts present always the same appearance. There is no change either of shape or of light and shadow. Hence one may affirm beyond any doubt that they owe their appearance to some real dissimilarity of parts. They cannot be attributed merely to the irregularity of shape, wherein shadows move in consequence of varied illuminations from the sun, as indeed is the case with the other smaller spots which occupy the brighter part of the moon, and which change, grow, shrink, or disappear from one day to the next, as owing their origin only to shadows of prominences. But here I foresee that many persons will be assailed by uncertainty and drawn into a grave difficulty, feeling constrained to doubt a conclusion already explained and confirmed by many phenomena. If that part of the lunar surface which reflects sunlight more brightly is full of chasms, that is, of countless prominences and hollows, why is it that the western edge of the waxing moon, the eastern edge of the waning moon, and the entire periphery of the full moon are not seen to be uneven, rough, and wavy? On the contrary, they look as precisely round as if they were drawn with a compass. And yet the whole periphery consists of that brighter lunar substance which we have declared to be filled with heights and chasms. In fact, not a single one of the great spots extends to the extreme periphery of the moon, but all are grouped together at a distance from the edge. Now let me explain the twofold reason for this troublesome fact, and in turn give a double solution to the difficulty. In the first place, if the protuberances and cavities in the lunar body existed only along the extreme edge of the circular periphery bounding the visible hemisphere, the moon might, indeed would necessarily, look to us almost like a toothed wheel, terminated by a warty or wavy edge. Imagine, however, that there is not a single series of prominences arranged only along the very circumference, but a great many ranges of mountains together with their valleys and canyons disposed in ranks near the edge of the moon, and not only in the hemisphere visible to us, but everywhere near the boundary line of two hemispheres. Then an eye viewing them from afar will not be able to detect the separation of prominences by cavities, because the intervals between the mountains located in a given circle or a given chain will be hidden by the interposition of other heights situated in yet other ranges. This will be especially true if the eye of the observer is placed in the same straight line with the summits of these elevations. Thus, on Earth, the summits of several mountains close together appear to be situated in one plane if the spectator is a long way off and is placed at an equal elevation. Similarly, in a rough sea, the tops of the waves seem to lie in one plane, though between one high crest and another, there are many gulfs and chasms of such great depth as not only to hide the hulls, but even the bulwarks, masts, and rigging of stately ships. Now, since there are many chains of mountains and chasms on the moon, in addition to those around its periphery, and since the eye, regarding these from a great distance, lies nearly in the plane of their summits, no one would need wonder that they appear as arranged in a regular and unbroken line. That concludes part 1 of Starry Messenger by Galileo Galilei. If you enjoyed, please like, subscribe, and tell your friends. Here at Small Anthropoids, similar to the universe, we keep our secrets so well, occasionally they are secrets to us. In other words, next week will be a surprise. Rest assured, we will finish Galileo's story, but if the whim strikes, we may also delve into Hypatia of Alexandria. I know, it's getting crazy around here, folks. As the first known woman in astronomy and mathematics, much of Hypatia's work has been lost to history in 2 ways. 1, when she was brutally murdered for being a sorceress, and 2, when the Library of Alexandria was burned to the ground. Although her exact words have been lost, it is important that her contribution to astronomy and mathematics not be erased by the sands of time and the people in history who were scared. Galileo and Hypatia's stories of sacrifice for science are pivotal and will be told. But like the universe, we too will reveal our secrets in time. Tune in next week to find out which we explore. Thank you for listening. We hope you found that any feelings of small were not scary. Stay curious and take care, small anthropoids.